Good evening, good morning, good afternoon. Put 23 people, 23 random people in a room. What is the chance that at least two of them share a birthday? What is the chance that at least two of them share a birthday? Most people say 2%. Others say about 5%. But mathematics say the probability of 23 people in a room, at least two of them sharing a birthday, is 50%. This probability does not apply to 100 or apply to 1,000. It only applies to 23. And this is called the paradox of birthday. And it reveals something uncomfortable about human intuition. It tells us that human intuition is terrible when guessing uncertainty. Welcome to another video exploring philosophical ideas that I think everyone should know. Most of us, we have experienced mathematics from primary school, high school, and some even to college. And our experience of mathematics has always been about calculation. You met mathematics through equation, through symbols, through abstract formulas, completely disconnected from ordinary life. It's not unusual for us to say, where will I ever use the quadratic equation? But mathematics is not just calculation. It's a way of understanding reality. And today, I want us to explore one aspect of mathematics that forms a very practical idea of maths. And this is probability theory. Probability is the mathematics of uncertainty. That's the definition of probability. Probability is the mathematics of uncertainty, trying to assess the likelihood of something happening. It studies just one question: how likely is something to happen? When talking about probability, which is a language that all of us use, normally what you are actually talking about is between 0 and 1. What is the likelihood of something happening? And that means the probability space is between 0 and 1. In other words, most of the life happens between 0 and 1, where 0 means impossible, it will never happen, and 1 means certainly it will happen. In between 0 and 1, that's where most of our life do happen. So I want you to imagine you're flipping a fair coin. That a fair coin just means, in mathematics, just means it's a balanced coin. It has equal chances of flipping heads or tail. So I want you to imagine there are two outcomes, heads or tails. What is the probability that when you flip this coin, it will turn to heads? Since there are only two options, the chance is 1 out of 2, which makes it 0.5. The chance for tail is half. The chance for head is also half. And that is the probability of flipping a coin to get heads or tail is always 0.5. What you should notice there, that when you add 0.5 plus 0.5, you get 1. So you can see that the chances of getting head or tail is half, but when you add those chances, it always gets you to 1. Let's look at probability of rolling a die. A die has 6 sides. So the probability of getting a 6 is 1 out of the 6, which is about 0.167. When we get these numbers, like the half or 1 out of 6, this is not just a guess. This is not magic. It's a structured way of measuring uncertainty. Probability is used in many areas of life. So whether we are using a weather app to try and predict the weather, what we are doing is we are trying to play with the probability space. So when your weather app says that there is a 30% chance of rain, that does not mean that the rain will cover only 30% of a geography, or it will rain on you 30%. It means that in similar weather condition, or the data that has been collected by your weatherman or your app, it means that 30 times out of 100 it rain. In other words, given the condition you have, or the weather elements the weatherman has collected, in such condition, out of 100, it has rained 30 times. Now, when you understand that, then you can now start seeing how probabilities are real in real life. Because then suddenly, 30% out of 100 suddenly tells you something about whether you should have an umbrella or whether you want not to carry an umbrella. And now you can see that probability is playing a role in decision making. But probability becomes more interesting when we combine events. So I want you to think about that you have 2 coins that you're flipping. What is the probability to land both heads? Each coin has a probability of 1 out of 2. Therefore, you have 2 1 out of 2. So what do? This is a probability of 1 and another 1. And since the probability of the first coin is half and the probability of the second coin is half, we multiply. And therefore, the probability of both coins landing heads or tails is a quarter, 25% chance. This works because the 2 coins are different or separate. In probability, we call them different events. One coin's outcome does not affect the other coin. So one coin does not care what the other coin did. And that's why they both maintain half-half probability. And therefore, both coins, their chances of coming out both heads or tails is 25. Now I want us to look at how we can apply probability in our daily life. Imagine you take a bus somewhere regularly, and your bus is late 20% of the time. And you also take coffee or tea in a certain restaurant as you wait for your bus. And your coffee order is delayed 15% of the time. Now you're waiting for this bus. What is the chance that both your bus gets late 20% and your coffee is delayed 15%? That's interesting mathematics now. So what do we do in probability? We take the probability of the bus delaying and the probability of your tea delaying, and we multiply. And we get 0.2 times 0.15 equals to 0.03. That means the probability of your bus delaying and your tea also delaying is 3%. This kind of computation helps you to see or not to exaggerate something, not to see catastrophe everywhere. And that's what's interesting about probability. But now let's reach for a more deep idea of probability. And this idea is called the expected value. The expected value helps us in areas of probability, like when you're playing games in a casino, when you're buying lotteries, or when you're insuring your property, or when you want to get into an investment. The expected value asks the question, over the long run, what outcome should I expect on average? On the long run, what outcome should I expect on insurance, on investment, on lottery, or playing the casino? So let's use the example of casino and think of a situation where you're buying a lottery ticket of 2 shillings and the jackpot is 1 million shillings. When you look at it, spending 2 shillings to a possibility of winning 1 million shillings, that sounds really exciting. But think of it again. Suppose 14 million people have bought the same ticket, which makes your chance of winning 1 in 14 million. What does the maths tell us in that case? Mathematically, in that case of 1 in 14 million, it means your expected value is almost negative 2 shillings. And that, once you understand that, that changes the meaning. It means, on average, you lose almost your entire ticket every time you buy. In other words, you lose your 2 shillings. And now you can see why your sports pesa, betting, and all those other gambling things that you do, why they have really low chance. But that's not the end of probability. Probability is also useful in decision making, in trying to make some changes. And it can help us to change how we think. Good decisions are not just about what is possible. They're also about thinking about the possibility or the probability and their consequences. So, when reasoning for decision, you think about the probability and the consequence and multiply them. When you multiply them, that's when you know how you're going to make a decision. So if the probability is half and the consequence is really high, then that calls in for a different way of thinking. And that's the hidden mathematics of rational decision making. Another area that you need to pay attention to in probability is called the false positive trap. Take, for example, a disease affects 1 person in 1,000. There is a test that is 99% accurate. You have tested positive. What are the chances you actually have the disease? Most people say the chances is 99. But the real answer is actually much lower. It's around 9%. You ask why? It's because even a very accurate test creates something called the false positive. This is because when the disease itself is extremely rare, most positive results come from healthy people. And this is where this false positive is important in what we call conditional probability. And now, when you understand that, you find that probability is no longer just some abstract mathematics. It is something that we use in medical reasoning. It's useful in risk assessment. It's useful in interpreting news. It's very important in critical thinking. And as you begin to understand probability, you notice that you notice something very important, that probability does not eliminate uncertainty. It helps us to organize uncertainty. And this leads us directly to another knowledge area called philosophy. And the part of philosophy that probability leads us clearly to is called epistemology. Epistemology asks, how do we know what we know and what are its limits? If we know something from probability, what are the limits of probability? Most human knowledge is not absolute certainty. We know things just to a matter of degrees. And when you know something to a matter of degrees, that is probability at work. So probability calculation turns uncertainty into something that's somewhat measurable and something that we can reason about and we can now structure it. And that's the importance of probability in knowledge. And that's why you studying probability or knowing something about probability is important. Now, once we know how probability works, this raises another question. Not a question of now what is likely to happen, but what should we do now that we know the probability of something happening? And this, what should we do, is the question now in another philosophy area called ethics. Ethics is about the value of what we do. Now, if there's a tiny probability of a catastrophic event, we can ask ourselves, how seriously should I take this? What level of risk is acceptable? And who gets to decide what risk should be taken and what is acceptable? So in this sense, we can see that probability does not help us to answer the moral question, but it helps us to think about the moral question intelligently. Another area where probability is important is called the law of large numbers. Probability is not mainly about predicting single events like the one we have already talked about. It also helps us to predict or give us an understanding of patterns over a long period. So for example, a casino may lose money tonight or today, but over millions of games, thousands of games, the mathematics always stabilizes such that the casino will have an advantage. In what casino goers or players say, the house always has an advantage or the house always wins. And the house always wins because of the probability phenomenon called the law of large numbers. So, next time you are checking the weather situation, think of probability. Next time you buy a lottery ticket, think of probability. Next time you hear of scary statistic, think of probability. Next time you're making an important decision, think of probability. But what I want you to really know is that probability is not magic. It's humanity's attempt to think clearly in a world where certainty is impossible. So to understand probability is to understand how to act in an uncertain world in a more reasoned and structured way. You need probability understanding to think analytically and to think critically. Probability is part of logic. I hope you have enjoyed another of my video of philosophical ideas that I think everyone should know. Make a comment and let's keep engaging.